We will finish filling in the unit circle by filling in all of these coordinate points that you find going around the outside of that circle. The definition of a unit circle is that the radius is always 1. All these lines that you see drawn are understood to have a distance of 1. So let's start right here by filling in what this point right here would be. This distance is 1. I did not go up or down at all, so that point is 1, 0. Right here, I went up 1. I did not go over anything. So the x is 0 and the y is 1. The point that goes with 180 degrees, I went out 1, but I went out to the left. So this point is -1, 0. And at 270 degrees, I went down 1. I did not go left or right at all. This point is 0, -1. To fill in the rest of the points, it helps to understand some things about right triangles that you would have learned in geometry. So let me start right here with this 30 degrees. If I turn this into a right triangle, so it might fit and kind of look something like that. If you have an angle that's 30 degrees in a right triangle, and we're making the hypotenuse 1 because this is on a unit circle, and this is a right triangle, so this angle is 90 degrees. The side opposite 30 degrees is going to be a half. If you measure this, this would be half of the distance. So I don't know this leg of that triangle. The Pythagorean theorem can help me figure out how long that is. So a squared plus b squared equals c squared. If you square 1/2, you get 1/4. If you square 1, you get 1. If I move this over, 1 minus the 4th is 3/4. To solve for a, you would square both sides. Or you would square root both sides. So the square root of 3, I would leave that. Square root of 4 is 2. So that horizontal distance is the square root of 3 over 2. If I go back to my unit circle and fit that in, this point right here is the square root of 3 over 2 and a half. (45 degrees to find that point. That is another popular right triangle from geometry. If you have 45 degrees in a right triangle, this angle must be 45 degrees also. So if those are the same angles, the sides opposite them must be the same. So I'm just going to call them x. Using the Pythagorean theorem, x squared plus x squared is 1 squared. X squared plus x squared is 2x squared. And to solve that for x, you would divide by 2. And then square root both sides. The square root of 1/2 simplifies. If you rationalize the denominator, that's something you would have done in Algebra 1 probably. That becomes the square root of 2 over 2. So on your unit circle, when you are at 45 degrees, that point must be square root of 2 over 2 and the square root of 2 over 2. You're to 60 degrees, and 60 degrees we've actually already done. If you have a right triangle and one angle is 30 degrees, the other one must be 60. So I'm going to take my answers and just reverse them for 30 degrees. So 60 degrees is 1/2 and the square root of 3/2. If you go on to take pre-calculus or college algebra, this unit circle will have to be memorized, but it's not as bad as it looks, because now that you've done all that, you are going to line things up to finish filling this in. For example, when I go over here to 120, that lines up perfectly with my answer for 60 degrees. That means they've got the same y value. X value is the same, but negative. At 135 degrees, lines up with 45. X value is the same, but negative. And y value is exactly the same. Same idea with 150 degrees. Make your negative x, but make your y positive. When you get to quadrant 3, everything in quadrant 3 is negative. So I'm going to line up with things I've already done. Just make both points, both values negative. Then in quadrant 4, x's are positive, but y's are negative. And that is your unit circle. You may find this online also and just copy it from maybe a website if you're having trouble seeing what I wrote. Just filling this in from your binder and sending me a picture of it in email or Google Classroom will be worth making 100.